Okay, so it says the length of adult males' hands are normally distributed with mean 191, standard deviation 7.5. Suppose that 15 individuals are randomly chosen. Round all answers to 4 where possible. Okay, so we're talking about a group again. So what is the distribution of, notice this is X bar, isn't it? Which is the average. So what is it going to be? It's going to be the mean. And they said the mean is 191. And then it's going to be the standard deviation, 7.5. It's going to be standard deviation divided by the square root of n, because this is X bar. This is the average of a group. So that's going to be 7.5 divided by the square root of 15, because this group size is 15. So I'm going to crank that out. And I'm getting 1.93649, so that'll round to 5. There we go, 1.9365. Then, next question, stop me if you have questions on this. All right, next question. For the group of, part B, for the group of 15, find the probability that the average hand length is more than 188. So, it's good to draw a little bell curve. Be helpful. There's my bell curve. Right in the middle of the bell is the average, the mean, which is 191, right? That's the mean. And they're saying, find the probability that the average hand length is more than 188. Where's 188? Well, that's a little bit to the left, isn't it? 188. And they want more than that, so they want shading to the right, don't they? Because that's more. You with me? That's more. More is to the right. So they want to the right of 188. So remember what's important when we do our thing. We're going to do, so now for part B here, I'll do it down here. For part B, they're saying find the probability. So that means they want me to come up with a percentage or a decimal, right? So go to your notes, exam 2 notes here. It says, when they ask you for a percentage, you got to do normal CDF. And if the n is more than 1 for a group, you got to divide standard deviation by the square root of n. So I'm going to do normal CDF because they're asking for a percentage, a probability, a decimal, right? And so let's do that. So this will be normal CDF, and they always ask you for lower or left, upper or right, mean, and standard. Okay, so what is the lower or left edge? Remember, we're talking about the left and right edges of the piece of shading. Are you tracking with me? Are you hearing me on that? So that's what we're talking about. We're talking about the left edge and the right edge of the piece of shading. So here's the left edge, 188. What's the of the shading? That's the left edge of the shading, isn't it? That's why I draw the normal curve and shade it. And how did I know where to shade? Well, they said more, right here, they said more than 188. So I had to shade to the right of 188. That's the more, is to the right. Okay, so now what's the, so that's the left edge. What's the right edge of the piece of shading? The right edge is way over here, isn't it? Here's the right edge. This is the left edge here. The right edge is basically infinity, isn't it? So we just put in a whole bunch of nines. Remember, like 6 nines or something? That's how we tell the calculator, go forever to the right, infinity, because the shading goes forever to the right. The mean, 191. Standard deviation, this is where we do the 7.5 divided by the square root of 15, because we have a group. They said for the group of 15. So there we go. Put that all into your calculator, and good things will happen. I'm going to go on to part C. If you're good, feel free to speak up. If you want to talk about it anymore. For part C, it says find the first quartile for the average adult male hand length for this sample size. All right, so part C, coming on down here, part C, they want Q1, right? First quartile, Q1. So you know how to get Q1, right? We've got to go to inverse norm, and they're going to ask us area to the left. For Q1, we know that's 0.25, right? Because if you're at the end of the first quarter, that means you're 25% of the way along. And they want mean. The mean is still 191. Write that a little better. And then the standard deviation, we have to take the 7.5 divided by the square root of 15 because we have a group, right? And we're talking about the average hand length for the group. So there we go. That'll give you the answer to part C. Finally, lastly, we've got part D. What's the story for part D there? It says, is the assumption that the distribution is normal necessary? Is that a necessary assumption? What's our answer to that question? Is it yes or no?
It would be no.
Right. This one's a no. Oh wait, oh, I'm sorry. I'm getting confused. This
It's a yes, isn't it?
Yeah, this one's a yes, because the group is less than 30. The size of the group is less than 30. Right, our group size is 15, right? 15 individuals. So 15, so whenever your group size is less than 30, you do need to be told that the distribution does fit a bell curve, a normal curve, because you won't have it automatically. Only statistical science has proven that if we have groups of size 30 or more, then the averages of those groups will automatically have to be normally distributed bell curve. But if the group sizes are less than 30, we don't know that automatically, so somebody has to tell us, hey, I graphed this data already, and it was bell curved. It looked like a bell curve. It was a normal curve, normally distributed. So yes, we would have to be told this data is normally distributed. So just put that in your notes. It's all about, it's a yes, because the group size is low. So yes, we need that assumption. It's no if the group size is 30 or more. So there we go. Questions on that one?